inverse y by x will be just minus 13.05 degree. So the source current is V by Z. V is 200 given in the problem. That is definitely the source, the RMS value. As I told you earlier, that always in the problem, in the circuit diagram, RMS value of source voltage will be given. If it is given in the form of say 100 volt or 200 volt, always you should consider that volt as the RMS value. If it's a maximum value or the peak value, then definitely it will be mentioned in the problem. But if nothing is given in the problem, always you will assume that source voltage or source current is the RMS value. So here V is the 200 volt RMS, the supply voltage, divided by the impedance 18.49. This is the magnitude. This is only the magnitude. Okay, so it's 10.81. And how to calculate the angle? How to calculate the angle? Here, this voltage is having 0 degree. And what is the angle of this impedance? It is minus 13.05. So finally, the current value is 10.81 angle 0 minus 13.05. That means only 13.05 degree. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
This is theta. This is theta. Theta means this one, tan inverse y by x, or this minus 13.05. Move on to the next problem. Okay, I guess I have already done this problem. Okay, so this is the similar problem. I hope all of you can solve this. You can just copy down the circuit diagram. It is again two impedances in parallel mode connected with a AC supply 230 volt 50 hertz. And you have to calculate the equivalent circuit impedance that you can calculate, which is just the parallel of the two branch impedances. So this is Z1 and this is Z2, right? So Z1 parallel Z2 is equal to the equivalent circuit impedance, right? The resistance and reactance can be calculated from the expression of the overall impedance of the equivalent impedance and the supply current. Supply current will be calculated by using the relationship V by Z. Look at the problem. First, you have to calculate Z1, the impedance of the first branch, the branch containing resistance and inductance, R plus J XL. XL is the inductive reactance, which is just equal to omega L. XL is just equal to omega L. Omega is 2 pi f, the angular frequency. Frequency is given in the problem. It's 50 hertz. Similarly, you can calculate the impedance of the second branch, which is just in parallel with the first branch, but the second branch is containing the capacitance, so you need to calculate the capacitive reactance, and this time impedance will be represented as R minus JXC. Okay, R minus JXC, because XC is 1 by omega C. XC is 1 by omega C. Fine, so omega is 2 pi f. So you can calculate Z2, I guess this will be Z2. And since they are in parallel, Z1 parallel Z2 will be calculated as this, either 37.34 plus J 16.96 ohm, or in polar form it can be calculated as 41 ohm with angle 24.43 degree. That means here the overall resistance will be calculated from this expression, that is 37.34 ohm And what is the reactance value? Reactance value is definitely the coefficient of the complex operator J, right? So here reactance is 16.96. The equivalent reactance is 16.96 ohm. Fine. And then the source current will be calculated by using the formula V by Z. V by Z, V is 230 volt RMS, Phase angle was 0 as given in the problem, and Z is 41.24 degree. So here, how do you calculate the magnitude of the current value? You will consider only this magnitude part. 230 by 41 is 5.61, and angle will be calculated as 0 minus 24.43 degree. 0 minus 24.43. So angle theta 1 divided by angle theta 2 can be calculated, can be simplified as angle theta 1 minus theta 2. Okay?
Ma'am,
Oh, yes.
ma'am, why the equivalent reactance is the imaginary part of Z? Like that part, I didn't understand.
Wait. Wait a minute. This is the overall impedance. Let me take the point of this. This is the overall impedance.
Yes, ma'am.
I got it, which is just
Yes,
parallel
ma'am.
Z1, Z2, right?
Hmm.
So any impedance can be represented as Z equals to R plus Jx, where R is the resistance.
But ma'am, why are we only considering the imaginary part?
Wait, let me write first. Impedance, what is the definition of impedance? R plus Jx. R plus
Yes, ma'am.
Jx.
Yes.
R plus Jx, right? Or Jxc minus XL, or JXL minus XC, depending upon the type of the reactance present in the circuit. But in general, impedance will be represented as R plus Jx, right? R plus Jx. That means this R is the real part and this X is the reactive part or the imaginary part. R means resistance, X means reactance. Okay. What is R? It is the real part. And what is X? It is the reactance, the imaginary part. If I draw this real and imaginary axis, we'll get this type of. This is the imaginary axis, IM, the y-axis, and this is the real axis, RE, marked as RE. Right? So this Z is nothing but if it is in the form of R plus Jx, that means R is the real part, this, and X is the imaginary part, like this. Just try to remember the impedance triangle. X is the, considering inductive reactance, definitely, you will get the impedance like this, the hypotenuse. Okay, that's why
Okay, ma'am.
R is the real part and X is the imaginary part. This is X. The pointer is not working correctly. Okay,
Okay, ma'am. Understood.
understood. So that's why from this overall impedance or from the equivalent impedance, we'll calculate resistance as the real part and reactance as the imaginary part. Because always the impedance of any circuit will be represented as R plus Jx. Where R is the real part and X is the imaginary part. Shall I move to the next problem?
Yes, ma'am.
Okay,
Yes, ma'am.
just wait. So I think you can solve this type of problem also. Okay, no. Here actually you are supposed to find out the powers, apparent, active, reactive. The circuit is simple. Only two branches are in parallel. So definitely first you will calculate the impedances of these two branches. So quickly you calculate first the overall impedance, because your question, first question is to calculate the total impedance. So quickly calculate the total impedance and supply current. These parts you can calculate on your own now. Next I'll show you how to calculate different types of powers and the power factor. Your first branch is containing a capacitor 150 microfarad and the second branch is containing an inductor 320 millihenry. So the first branch impedance is Z1 will be calculated as, who can tell me what will be the generalized expression of impedance of the first branch, say Z1.
75 minus J into
J into
Ma'am, 75 plus 2, 1 by
Ma'am,
2 by 150,
75
to
minus
150.
j into 1 by 2 pi
no.
150
First,
equals
first you tell me the generalized expression.
In the lower branch R minus JXP, and in the upper branch R plus
plus
JX.
jxl.
JXL. Okay. Now R is 75. R1 is 75 and R2 is 32, 30. Now
Yes, ma'am.
what is XC? How do you calculate XC?
1 by omega c.
Right, 1 by omega c, and omega is 2 pi f. F is 50 hertz. And what is XL? What is XL? The
Omega
inherited
L.
reactance omega
Omega
L.
L, 2
Omega
pi
is 2 pi.
fl.
Okay, so it's 2 pi FL. So quickly calculate the total impedance and the supply current. Have you got the answers? Mhm. Impedance. Impedance of the RL path and impedance of the RC path. Are calculated as 30 plus J 100.53 ohm and 75 minus J 21.22 ohm respectively. So the overall impedance, the equivalent impedance is 58.2 plus J 21.78 ohm, or in polar form it is 62.14 angle 20.52 degree ohm.
Yes, ma'am.
Anyone is having any type of queries, confusions regarding this type of problems? If you have any questions, any doubts, you are free to ask. Yes, it's a tutorial class, so if you have any types of confusions, please let me know now.
I'm just
We're
having
just
difficulty.
learning. Yes, yes, yes. Please tell me.
Just having difficulty calculating. Calculate.
This calculation part, this last calculation part.
Yes.
Yes, that you have to do. I guess all of you have studied this type of complex algebra in your class 2 mathematics. There was a chapter named as complex algebra in mathematics. So you
Yes,
have that.
ma'am. Complex
I,
number.
I complex, yes, operator as I probably. So you know how to solve this type of algebra arithmetic. Okay. Next I, the current V by Z is 200 angle 0 degree. Next, power factor, cos of phi. Right, as I told you that phi, the cosine of phi is called the power factor. And what is this phi? This phi is nothing but the phase angle between the source voltage and the source current. Right. So what is the angle associated with the source voltage? 0 degree. What is the angle now associated with this current? Minus 20.52 degree. Now can anyone tell me what is this minus sign indicating actually in practice? There is a, specific significance of this negative sign.
Yes, current is lagging by voltage 20.5.
Absolutely correct. Yes. It signifies that the source current is lagging by the source voltage by this angle 20.52. So if you draw the phasor diagrams, you will see that current is lagging type. So definitely we'll get lagging type power factor from this type of circuit. That means your load is more inductive. The load is more inductive. Okay. So definitely phi is here minus 20.52. So cos phi is cosine of 20.52 degree, which is 0.937. And since you have understood how the current is situated, it is just lagging by this angle with the source voltage. So we can write here within bracket that it's a lagging type power factor, right? Next, apparent power. Apparent power is just the product of RMS voltage and RMS current. Already we have calculated RMS current, RMS voltage was given in the problem. So this is the value 644 volt ampere or 0.644 kVA, kilovolt amperes, the value of apparent power. Okay, and active power is capital P, which is VI cos phi. Reactive power is capital Q, which is VI sin phi. If you follow the power triangle, you see P is the base, Q is the height, and S is the hypotenuse. Right? The resultant vector of the power triangle. The cos phi is already calculated. Sin phi will be calculated as, how do we calculate sine if cosine phi is known? How to calculate sine phi?
Root under 1 minus cos square phi.
Yes, because sine square phi plus cos square phi is equals to 1, the basic mathematics. So sine phi is equals to square root 1 minus cos square phi. Okay, so this is the value of reactive power, 226.04 volt ampere reactive. So we'll directly write VAR. This R is not suffix. We'll write VAR. VAR. R stands for reactive power. Okay, and the unit of active power is watt. So either you will write 603.43 watt or you will write 0.60343 kilowatt. Okay, next. Example number 3.12. Try to draw the circuit diagram. A series circuit has a series resistance of 2 ohm, an inductance 0.25 Henry, and a variable capacitance. The value is not known. Connected across 230 volt 50 Hz supply. Calculate the value of capacitance for resonance. That means the value of capital C during resonance condition. Voltage across inductance and the capacitance at resonance, and the quality factor for the circuit. Okay, so for series resonance, we know this condition. Capacitive reactance must be exactly equal to the inductive reactance. XL should be equal to XC at a particular frequency 50 Hertz, which is given, which is mentioned in the problem. That means omega L is equals to 1 by omega C. XL omega L 2 pi FL, and XC 1 by omega C 2 pi FC. So from this, we'll be able to calculate capacitance C, which is just 1 by 4 pi square f square L. So this is the expression of capacitance during the series resonance. Okay. So all the values are known. We can calculate C. The value is 40.53 microfarad. Now, second question is voltage across inductance and capacitance at resonance. Voltage across inductance means BL, I times XL. And voltage across capacitance means VC, I times XC. Okay. So what is I? I is at series resonance. I is simply V by Z naught, correct? And what is Z naught? Equals to R, the circuit resistance, because the circuit will behave as a purely resistive circuit during series resonance. Okay, so it's just equal to 2 ohm given in the problem. 2 ohm. The circuit has a resistance of 2 ohm. So I naught is 230 by 2, 115. So voltage across capacitor is I times XL. Voltage across capacitor will be also equal to the voltage across inductor. So we can directly write here 9032.1 volt. Or you can calculate VC as I naught times XC. You'll get the same value. And using this mathematical relationship of Q, you can calculate the quality factor Q as 1 by R square root L by C. This is the mathematical expression of quality factor for a circuit at resonance, at series resonance. The value is 39.27, right? And it is unitless. All of you have understood this problem? Any question to this?
No.
I hope I have shown all types of problems from AC circuit. Now, if you have any doubts or any queries, you can ask me. All of you have understood all types of problems?
Yes, ma'am.
Okay, so just wait. Is the screen visible to all of you?
Yes, ma'am.
Yes, ma'am. Please copy down these two problems. The first problem is a coil of resistance 2 ohms and inductance 0.01 Henry is connected in series with a capacitor across 200 volt mains. What must be the capacitance for maximum current at 25 Hertz? Find also the current and voltage in the capacitor. The answers are given. You have to find out the answers. And the second problem is a resistance of 100 ohms is connected with an inductance of 1.2 Henry and capacitance of 10 microfarad in series. The combination is connected across 100 volts and 50 hertz supply. Find current in the resistance, voltage across the capacitor, power consumed, and also draw the phasor diagram. So, all of you, please solve these two problems.
Yes,
At
ma'am.
spare time, not now. Okay, so this is your homework actually. And tomorrow, when we meet again, you please let me know if you have any doubts or any confusions regarding this type of problems. Okay, so today in the class, we have solved few problems, numericals from AC circuit, and these two are almost similar to those problems. Now, one thing I would like to know from your side, in the first problem, marked as problem number 8 here, this statement, follow this statement. What must be the capacitance for maximum current? Can anyone tell me what is the significance of this line? Is there any significance, any importance of this line?
Resonance frequency, ma'am.
Resonance frequency. Yes, you are absolutely correct. Who is this? Who is this? What is your name?
Farhan Ahmad, ma'am.
Farhan. Okay, you are right, Farhan. So maximum current at 25 hertz means that the resonant frequency is 25 hertz. Okay, and maximum current. We're talking about maximum current. Then what type of resonance? It is definitely a resonating circuit. Then what type of resonance we should expect at 25 hertz? Series resonance or parallel resonance? Can anyone tell me? In which type of resonating circuit at resonant frequency the current will become maximum?
Series.
Series resonance.
Yes,
Series. Yeah.
series resonance, right? So in the circuit, see, it's already mentioned resistance and inductance are in series, which is in series with a capacitor whose value is unknown here. That means from the statement of the problem, always the circuit diagrams will not be given. From the statement itself, you have to find out, you have to analyze what type of circuit it is and what are the parameters you need to find out to calculate the final parameters given in the problem. Okay, so all of you will try to solve these two problems, okay, on your own. So if you find any discrepancy, any problems, any confusions, please let me know in the next class. Okay, and tomorrow I'll be continuing with power converters, DC-DC chopper circuits. Okay,
Yes,
Okay,
ma'am.
ma'am.
okay, ma'am. Thank
Okay,
you
ma'am.
for your attendance.
Ma'am, in first one, answer of current is not given.
Just wait. Find also the current and voltage in the capacitor. Yes, answer is not given. You are right. So VC is given, right? 157. That means you can find out VC first, the voltage across capacitance. And if you know the capacitance value, definitely you can calculate the current through the capacitor because I times XC is equals to VC. XC can be calculated because C is now known to you. VC is already calculated as 157 volt. But answer is not given, yes. But you can calculate it from these two values, VC and C. Okay? And
Okay, ma'am.
second problem, please try to draw the phasor diagram. It's very, very important to understand phasor diagram. Okay. So if you find any types of problems, please let me know in the next class.
Okay.
Because if you can draw the phasor diagram, that means you have understood everything. Just wait, let me take your attendance. Roll 1,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5. Aditya Banerjee.
Present, ma'am.
Okay, 6,
Present, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12, Sattam, 13,
Present, ma'am.
14.
Present, ma'am.
You were absent in the last class?
Yes, ma'am.
Okay. 15,
Present, ma'am.
16,
Yes, ma'am.
17,
Yes, ma'am.
18,
Present, please, ma'am.
19. Chandrani,
Present, ma'am.
20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
23,
Yes, ma'am.
23 and 22. Both of you were absent in the last class. Chomen and Shia.
Yes, ma'am.
Yes, ma'am.
24, Shagnik Ghoshal.
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30, 31,
Yes, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Yes, ma'am.
36,
Present, ma'am.
37,
Present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41, Niladri.
Ma'am, he has written in the chat box.
Okay,
Roll number.
okay, just wait. Niladri. Niladri, what happened to you? Your mic is not working or what?
Ma'am, maybe my mic is not working. It's written in the chat box.
Yes. Okay. After Niladri, roll number 42,
Present, ma'am.
43,
Present, ma'am.
44,
Present, ma'am.
45,
Present, ma'am.
46, 47,
Present, ma'am.
48,
Present, ma'am.
49,
Present, ma'am.
50,
Yes, ma'am.
51,
Present, ma'am.
52,
Present, ma'am.
53, 53, Ahona.
He's having mic problem.
Yes, I think so. He's there. Sorry, Ahona. He's there. I have marked you present, Ahona. Don't worry. Next, Strajal.
Present, ma'am.
55, Pratik.
Present, ma'am.
Okay. So, Shangita, Sattam are absent today, right? Okay, thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. You may now leave the meeting. And all of you are getting the